In this one, we'll be doing problems from your week 8. Okay. I'm assuming I'm audible. Can you please confirm? Okay. Analog circuits. And we'll be doing problems from, uh, the topics that would be revolving would be Zener effect rectifiers, clampers, peak rectifiers, super diodes, uh, your BJT DC circuits, uh, then will current mirror. I mean, these were the topics that we were taught in week 8, right? So, since we did not do any problems on them, we'll be taking up some problems in this session from these topics. Okay. So, let me quickly start the first problem today's session, which is as follows. Uh, for the circuit, let me draw the circuit. Suppose this is your circuit. Okay. Suppose we have a Zener diode here. This is I. This is IL. This is V naught. This is RL. Right. This is V, right? V would be the voltage across this. And yeah, this is I. Let this be V in. Sorry? Oh, screen is not visible. I'm my bad. Sorry. I think I forgot to share the screen. Just a moment. Is it now visible? Yeah. So this is the circuit, and we need to find the output voltage for say let's say Vi is how much? Say Vi. Uh, I mean by Vi I mean V input, right? Let's say if it's 1 volt, 5 volt, 10 volt, 15 volt. Fine. And this is your Zener diode. Okay. I hope you remember how the characteristics of Zener diode look like. If not, let me show you quickly. So this is V. Suppose this is I. Okay. This is how the characteristics would look like. right? Hmm, something like this. And this would be the breakdown voltage, right? Minus VZ. Okay. What you will assume is that you'll assume your VZ is 5 volt. You'll assume R is 5 kilo ohm, right? This R and RL. Suppose RL is also 5 kilo ohm. Okay. And you are required to compute the output voltage. Okay. Find, you need to find VO, right? Output voltage. How would you proceed on this one? Yes. For and also, uh, when will be the Zener diode in off condition? When your output voltage is less than 5 volts, right? So a simple voltage divider would tell us that V output would be RL whole divided by RL plus R times VI, right? This is your VI. This is VI. Okay, so this is voltage at this node, right? Voltage divider of this and this. Now, so I mean, since we know the values of R and RL, can we simplify this? Yes, right? So this would be 5 by 5 plus 5, that is 5 by 10, that is zero point 0.5. Okay, so this would be zero point 0.5 times of VI, correct? Therefore, now for different values of VI, we would have different output voltage, right? For VI equal to 1 volt, our output voltage would be zero point 0.5 volt. Likewise, for VI equal to 5 volt, our output voltage would be 2.5. Similarly, for VI equal to 10 volts, our output voltage would be 5 volts. VI equal to 15 volts, our V out would be actually this Zener would break down, right? I would say why would it break down? Because clearly V output would be greater than 5 volt, right? If we use this formula. So it breaks down and V output would remain as such, right? It would remain 5 volt. It won't exceed that. So that is how I mean Zener operates, right? Zener diode operates. Now let me take up another question. For problem two, let's say we are given the same circuit, okay? And I need to find same circuit. So if the circuit is same, I can even copy paste it. Okay, this is your circuit. Now, what do you need to find? You need to find V output for different values of load resistance, right? For RL equal to infinity, 5 kilo ohm, 2 kilo ohm, and 500 kilo ohm. 500 ohm, 500 kilo ohm would be a lot. Okay. I hope you are aware of this Zener diode model. You would have been taught this, right? If this is my Zener diode that is occurring between the nodes A and B, right? Suppose this is IZ, this is minus VZ. Okay. I mean plus minus VZ. So what is its equivalent? Its equivalent is it's as if you have a resistor of resistance RZ and you have a battery, DC battery, ideal battery, right? Of say potential VG not, okay, potential difference. A, and this is the same IZ that would be flowing here, right? And we'll have VZ drop cross occurring between the terminals A and B. Okay, so now we'll have some assumptions. Assumptions are as follows. Uh, we will assume quite a few things actually. Firstly, this test VZ not, right? Drop across these terminals A and B. Let's assume that this is 4.9 volts. Okay. Let's suppose your test current IZ, right? Let's say that is 2 milliamps. Okay. And obviously at some, say, test voltage VZ. Right. And this is a test current. Okay. Test current is 2 milliamps at some test voltage VZ, then IZ K. Right? How much is IZK, the knee current? Let's take the value of the knee current as 500 micro. Okay. Suppose your RZ, right? This RZ, internal resistance, whatever. Suppose that this is 50 ohm. Okay. And suppose your this R, that is 5 kilo ohm. This R, okay. And also suppose that your VI is 15 volts. Okay. Now for these different values of, okay, we need to find V naught. So how much is V naught? We can in fact replace the given circuit by the equivalent circuit first in order to find the values of the V naught. Right. So I'll write equivalent circuit. And wherein I'll be using this model, okay, instead of this. So this is how equivalent circuit would look like. This is what? This is R, which is 5 kilo ohm. Then you have R, then you have a battery. Okay, and suppose that you are having a resistor here. This is how much? This is RZ. This is how much? This is VZ naught. This is, wait, let's this be IZ naught. This is 50 ohm. VI is how much? 15 volt, right? VI was 15 volt. And this is what? This is your RL. So we'll have one, two, three, four cases, right? Let's take up case one. Okay, case one is what? The RL is infinity. For that case, so open up, right? And what will we have here? We'll have output is, sorry, please be a little loud. I'm not able to hear you. One five. No, actually. Let's see why. See, do you agree with me? If RL is infinity, we'll have an open circuit here, right? So this is the circuit that we have, and we need to find this. Means, I mean, in other words, if this is ground, this V naught is this potential we need to find, right? So we'll have two uh, actually batteries, right? The VI battery, right? This one and this one, and they are actually not in. I mean, they are in series, but they have opposite polarities, right? So they will subtract up. Do you agree? Yeah. So we'll have effectively the effective voltage that we'll be having if I traverse this loop and use KVL, it would be VI minus VZ naught. VI minus VI minus VZ naught would be the effective drop here. And if I and see the current flowing is IZ naught, right? So and the resistance in the path that is 5 kilo ohm plus 50 ohm. So V is IR. If I use Ohm's law, from Ohm's law, I'll have following V by R plus RZ. That would be my IZ naught, correct? And in fact, this is actually that particular. See, this is for test voltage, right? In my case, this IZ naught would be the IZ, right? So I can replace this IZ naught by 2 milliamps, correct? So how much would be, say, what the VZ naught? Your VZ naught, if you'll do the maths, it would turn out to be 4.9, right? And see, how much is this current flowing? 2 milliamp, right? I mean, even if you go by this one, right? Your I max, that would be 15 minus, sorry, minus 5 whole divided by 5 kilo ohm, that is 2 milliamp, right? So if this 2 milliamp current flows through 50 ohm of resistor, it would produce a voltage drop of zero point 0.1, right? You can check that at your end. And you simply need to multiply this with this. And therefore, if difference up to here is 4.9 and this is 0 0.1, then this whole would be 5, right? I can I can write as my V naught for this case would be 5 volt. Okay. Similarly, we'll have RL equal to 5 kilo ohm case, right? I'll quickly discuss these cases, I mean, and write the answers. Case 2 would be where RL is 5 kilo ohm. Copy, paste, right? RL. Yeah, rest of the things are fine. Now again, for this case, how much would be V naught? That would be 50 ohm parallel RL whole divided by 5 kilo plus 50 parallel RL. Right, times 15 volt obviously. Plus 5 kilo parallel RL whole divided by 50 plus 5 kilo parallel RL, right? So your V output would be equal to 4.95 volts. Similarly, we will do for the other two cases. Case 3, when RL is say 2 kilo ohm, right? Check that the V output that you'll get would be uh, also I forgot to mention that here IL would be how much? IL uh, would be this divided by this resistance, right? IL turns out IL is approximately 1 milliamp. Cross check it. Yeah. Likewise for RL equal to 2 kilo ohm, V output that you'll get would be 4.285 volts, and the IL will have would be approximately 5 by 2K, that is 2.5 milliamps. Now, this IL is greater than I, right? So again, the Zener diode will be in off condition, right? So in the last case, case 4, for RL is 500 ohm, right? For this, your V out would be 1.3636. Okay, so this is V output would be 1.3636 volts. Okay. Now let's take up another question. Question 3 would be let I mean keep the variables. I mean let's borrow the variables from question 2. All you need to do is same as Q2, but your source resistance. Our source resistance R, right? Suppose that it is changed to 2 kilo ohm. Okay. If you do that, you need to find the output. Okay. Can you do this? I mean, this is a repetition question, right? I'll leave this as a homework for you. I'll just write down the answers that you'll be getting. Okay. Now you'll be using R as 2 kilo. Right. Then again, you'll have case 1 where RL is infinity. Right. For this, now you'll obtain the output as 5.146 volt. Where I max would be 5 milliamp now. Okay, everything would change because our source resistance has changed. Similarly, when your RL would be say 5 kilo ohm, your V output would be how much? 5.096 volts, right? And yeah, your IL max would be, that would be 5 by 5 kilo, which is 1 milliamp, right? Similarly, when your RL would be 2 kilo ohm, your V output would be 5.0238 volts, obviously, right? And your IL would be how much? 2.5 milli. Okay. And when RL is 500 ohms, your output voltage would be, it would be 3 volts. Okay. So yeah, that finishes your question 3. So now we'll have another question. Uh, we'll take a 2 minutes break. Okay. We'll do some 6 to 7 questions more today. Oh, sorry, I was muted. So yeah, this is 2 kilo. This is 2 kilo. I'm drawing a circuit currently. Okay. And this is VI. Now, for this circuit, let's find out this VO. Okay. In other words, I want VO in terms of VI. Right. I want this in terms of this. Right. I'm interested in an expression. It might be the case that I'll not have a unified expression, but if even if a piecewise definition of VO in terms of VI exists, I need to find that out. Okay, so that would be uh, the problem for this one. So how should we approach? If my input voltage Vi, right, that is say less or equal to minus 2 volt, my V out would be V in. Right? Why? Because my both diodes will be off. Right? This will be off, this will be off. So there would be no current flowing, and this voltage would simply be this voltage because current flowing would be zero. Okay. It hardly matters if we have a resistor here. If current is not flowing, the potential of this and this terminal, let's say. So we are done with this. Now, what if I change the range from the minus 2 to how much? 4 volt. Right. For this one, your V output would be for this one, yeah, my V output would simply be Vi times 2K by 4K minus 2 volts times 2K by 4K, right, which is half of Vi minus 2. Right, for this range, this will be my V output, correct? Yeah. And for the range V when Vi is greater than 4 volts, my V output would be 1K by 3K of Vi. 3K of Vi. And then 1K by 3K of 4 minus 1K by 3K of 2. Right. So if you simplify this, your V output would be 1 over 3 Vi plus 2. Right. So this would be my piecewise definition of V out in terms of V input. Right. If my range is this, my V out would simply be V input. If my range is between minus 10 4 volts, I'll have this definition of V output. And if Vi is greater than 4 volts, then my V output would be this. Correct? Now let's take up another question, question 5. And in question number 5, we would be finding some, we'll be given some circuits and then we'll be needing to obtain their maximum peak inverse voltage that would be experienced by the diodes in the circuit. Just a 2-minute break again. Is the screen visible? Doesn't look so, I guess. Because that is stuck. Should be now, right? Okay, you need to find the maximum uh, peak inverse voltage uh, experienced by diodes, right? Uh, okay, we'll assume that your Vs is how much? Vs is 3 sine of omega t, right? And your threshold voltage of each diode, let me denote that by VTH, D, threshold voltage of the diode. Let's say it's zero point 0.4 volt for all diodes. Okay, I mean by threshold I mean the voltage that turns it on. Okay, it's threshold in that terms. So let's take up the first circuit, a half wave rectifier. I hope you recognize the circuit. Right. So this is Vs, a sinusoidal source. This is the diode. This is what? The resistance. Yeah. Let's say this is R and say this is VO. Okay. So how much would be the peak inverse voltage of this diode? This is your Vs. Okay. Use this. It would be 3, right? Because 3 is the amplitude of this sinusoidal frequency. And this is somewhat like this. 3 minus 3. And this is your Vs versus T. Okay. I'll directly write the answer because it's firstly this is a half wave rectifier circuit, right? And the peak inverse voltage, uh, let me denote that by Vm, that is 3 volts. Okay, so this is first part. For second part, let me take a full wave rectifier. Okay. How does a full wave rectifier look like? Uh, Actually, I have a modification for that. Let's say I have a following circuit. Let's say this is Vi. Okay. Okay. This is D2. This is D1. This is VS. This is VS. Uh, and let's suppose this is my V naught, which I am interested in occurring between the terminals of the R. Okay, now I need to find the maximum peak inverse voltage across D1 and D2. Okay, so how much should it be? It's a full rectifier, right? Where peak inverse voltage Vm. The cross check it that this would be 2 Vm minus Vd, which would be how much? 5.6 volts. Okay, and then I have another circuit. Let's say V naught is this. Okay, and let me mark them. The diodes D1, D2, D3, D4. Right, suppose you ground this one. Suppose this is VS. Okay. Now for the this bridge rectifier case, your peak inverse voltage would be this is Vm minus Vd, which is 2.6 volt. Done. Now question 6. For the circuit that is shown below, you need to find the output voltage V naught, right? For values of Vi. Let me draw the circuit for you. The circuit is as follows. This is 2R, this is 6R, this is Vi, this is 12 volt, this is minus plus, this is a diode, this is V now. D2, this is D1. Okay. So find VO in terms of Vi for this. For Vi, uh, if it's greater or equal to minus 4, your D1 and D2. Your D1 and D2 would be forward biased. Correct. For V input less than minus 4, your V output would be equal to minus Vi 2R by 2R minus 12 2R all divided by 6R. Your V output would be equal to minus Vi minus 4. Okay, so this is your question 6. What about the 7th? For 7th, you need to find VO at time T3. Okay, the circuit of interest would be following. You'll have a capacitor, you have a diode, you have a battery, you have a resistor. You have R, you have T naught, You have 2 you have 1 microfarad capacitor, you have Vi. And this is the P3 where you need to find V out, right? During T3, V input would be 5 volts, right? This is what V input would be. I did not write it, right? This is Vi versus T. This is 5 volt, this is minus 15 volt. And how much should be the answer then? See, VC would be 17 volt, Vi would be 5 volt, and your V output, that would be 22 volt. Okay, that finishes your question 7. Then we have 8th. For question number 8, I have the same diagram, okay? Find V output at time T4. At time T4 now, my V input would be minus 15 volt, correct? So also my diode would now be turned on, right? Diode would be turned on. So it will uh, if diode is on, we'll have 2 volt minus 0.7 volt, right? That is 1.3 volt here, right? And that is my V naught. Simple, right? A KVL here. I mean, in question 7, this was off, right? But in question 8, this is on. Now question 9. Let me draw a circuit. It's actually a biasing for a BJT, and you need to find the value of the collector current, assuming that VBE is base emitter voltage is zero point 0.7 volts. So this is how the circuit looks like. We have you need to find the collector current IC. Okay, assume that assume VB is 0.7 volt. Okay, okay, you will be needing this expression. I'll leave this as a notebook. Okay, use this. IE is 1 plus beta times IB. Expression. I'll be uploading the slides anyway, so you'll get the opportunity to try these. Sure. And then I have last problem, which also will be a homework problem. So a common emitter amplifier uh, is as shown. We'll have this will be as 3 volt. You'll have there's 100K resistor here, right? And this collector terminal. This is 3K. This is 10. Yeah. Beta is 100. We'll use a hybrid pi model and find R pi. Okay. This is what you need to find. I'll give you the answers though. For this one, the correct answer is IC is 0.29 million. And for this last one, for R pi, it's 1 kilo ohm. Okay. Attempt these and let me know if you have any questions by mail. Does anyone else, do you have any other question? If not, we can end this session here. And this was the last session of this 8-week course. Hope you found it fruitful. Any suggestions, feedback? Ravindra, Dhawan, no? No suggestions? Okay. Those who haven't joined this session and are watching this in the recorded form, if you have any feedback or suggestions on improving the content, you can mail me, okay? I assume you all have my email IDs. Or you can comment on the YouTube video as well. That's fine as well. I'll be stopping this recording now.